All right, welcome. I'm Rob Pleau, and today we're going to see if we can make PowerShell blazingly fast. The genesis of this topic came from I follow some YouTubers. One of them is the Primogen. He's also a Twitch streamer, and he has a whole series of videos about making different languages blazingly fast. And I thought it'd be fun to do it on PowerShell. So we're going to get into it. Quick thank you to all the sponsors for the event. So thank you. Quick about me. I'm a longtime PowerShell user, over 12 years, I think, maybe longer. I love Linux. I use Arch, by the way. This laptop's running Arch, so you can do PowerShell stuff on Linux. It's possible. I recommend it. I'm also a NeoVim enthusiast. If I can convert some people to use NeoVim, it's also a great... Okay, so we have someone in the front row who's also using NeoVim for PowerShell. I love it. So there's a whole two of us. There could be more. I have an unhealthy obsession with mechanical keyboards if you want. I put the specs down below because I had a question in one of the sessions last year. I did bring one with me if you want to see it. I have a neglected blog. I'm just going to be honest about it. I don't update it very often, but it is there. It has some okay stuff. And I love Markdown, so a lot of this is going to be terminal and Markdown. I'm going to make the Markdown a little bit pretty so we don't have to look at raw text, but... Oh, and that's a picture of me with a giant stone rabbit. So before we talk about performance, there's almost like an infinite number of variables. There's, obviously we're going to be talking about language selection and specific code pieces or code factors or code variables of the language you select, namely PowerShell in today's session. There's compute and hardware factors. So I did most of this session, built it at home on my home desktop, which has a lot of horsepower. So obviously the numbers that I ran there are different than this laptop. I actually have a second laptop with me. The numbers differ because different processors, different memory speeds. We're not going to really do much with networking, but that could be a factor. Are you on a 10 gig, a 1 gig? Are you on like 10 base too thin nut somehow? I hope not. Storage, if you have a storage intensive process, are you using a spinning disk? Is it a SSD? Do you have an NVMe drive? What are the speeds of all that? And then even environmental factors. So how hot is the laptop right now or how cold? So there's almost an infinite number of variables, but I will say in terms of what we're going to look at, if I took even the 3 machines I kind of put all of this together on, A should always be approximately faster than B. So for the most part, the numbers all kind of jive together. So, can we make PowerShell blazingly fast? No. We can't. So PowerShell is an interpreted scripting language. If you need raw speed and performance, you probably should use something like C# if you want to stay in the .NET ecosystem, or Go, or Rust if you're willing to go outside of .NET. So if we're going to compare PowerShell to a compiled language, or especially a compiled language that just gets compiled down to machine code, PowerShell will likely almost never win, so just keep that in mind. But we can make it blazingly fast compared to itself. So we're going to look mostly at optimizations we can make to improve it. And with that, we'll go to the demo. So, like I said, a lot of this is just I'm using Glow to render Markdown. Really to just keep myself on track, I'm going to copy notes out of it, but a lot of this is going to be using measure command. If you haven't used measure command, you could basically put some type of PowerShell within the expression parameter and get a time span of how long it took to run. So what I did is I ran a get time span diff%, which I'm going to be using in various parts throughout this. TSD, it's aliased for short, for time span diff, and it's going to use ticks, because it was just the easiest unit to do the math. I could use milliseconds too, and even doing the math there, it was always the same whether I used ticks or milliseconds. Ticks was just easier. And it's going to take the diff and give us the approximate, like, how much faster was one thing than the other. We're not going to use it for everything, but I will be using TSD, so just know it's taking 2 time spans, it's comparing them, and it's basically taking the faster of the two and giving some output on that. And I'm not a math major, so I have cross-referenced these numbers through like 5 different percentage calculators, like ChatGPT, Google searches, and I think I have it pretty refined, but if you find a mistake, let me know. But for the most part, the numbers are going to just show us, again, how much faster roughly was A than B. And what's a tick? If you don't know what a tick is, this is right from the .NET docs. It's just the smallest unit of time, at least in .NET that I know of. So 100 nanoseconds is like a 10 millionth of a second. So there's basically 10,000 ticks in a millisecond, but it's just a really tiny unit of time. And let's see. Oh, yeah, and the function, it's going to give speed improvement percent, time reduction percent, and then roughly how much faster it was. Was it faster by 2 or 50 or 100 times? So with that, let's take a look at it. Make sure I'm in the right place. And I'm not going to be using NeoVim. I'm just going to bat this because it still has syntax highlighting. But this is really all it's doing. It's just a little bit of math. And it's going to output those things. So that's pretty cool. So let's first get this into memory. And I'm just going to use TSD, so time span diff. So if I say, we'll say 2 and 4, and 2 is going to be twice as fast as 4. So that's really what it's going to be doing. We're going to be throwing some more interesting numbers at it. We could do it right now if I use numbers. Not used to this keyboard. So the 2,837 is about 1.3 times faster than the 3873. So with that out of the way, let's get into the fun stuff. Let's go to so what I have here, and let me just move this one too. So I wanted to start with a bubble sort because I wanted to show PowerShell's performance compared to something that isn't PowerShell. It's not even .NET. So if you don't know what bubble sort is, let's pull up the notes so you can read them while I talk. Ooh, that's the wrong file. There we go. If you don't know what bubble sort is, it's an algorithm for sorting generally like a list of numbers. I'm not going to get too crazy with algorithms. I'm not going to be talking about big O notation or anything like that. But what I've done is I've written a bubble sort in Go, and I've written a bubble sort in PowerShell, and we're going to just use it to compare. So we're going to have a list of 10 numbers, 100, I think 1,000, 10,000. We'll get to that. And I have the compile. It's already pre-compiled, so I'm not going to be doing that. I've already built it. It's in the directory. But actually, we'll just do this in the other one. If let's just take a look at the Go. That Go bubble sort main.go. So this is the Go code, and really there's a function that's doing the bubble sort, and the main process is taking in a file. It's just validating the file's real. It's an OS flag, so and then it's going to parse that file, and then which is just numbers. And then it's going to run a bubble sort on it, and it's going to output that at the very end. So line 52 is where it's going to do the bubble sort. And then similarly, we have PowerShell. I have this invoke bubble sort. It's doing the same thing. We're taking a file parameter. It's just going to validate that the file's real. It's there. It's going to parse it. Then it's going to do the bubble sort. So let's just, if I show you, I'll show you what's in the number list of 10. So we just have 10 numbers, 37, 90, 85. So the bubble sort's going to walk through this, and it's going to order them. So let's do it with Go first. So we'll do. Oh yeah, the HDMI, thank you for letting me know. The HDMI is a little finicky, so I'll try to type lighter. I didn't even touch it that time. All right. Ghosts in the HDMI. All right, I'll try to be very gentle. So just to show you these are working, I'm going to copy this, paste it, and I got to dot source it into memory. Hold on. Oops. There we go. And you can see the same output. So the bubble sort's doing what it should, just 10 numbers. So I'm not crazy. You know I'm not making this up. So now let's sort 100 numbers. And I have this wrapped in the measure command. And when I run it, we can see, and if you're curious, a lot of these times I'm doing t-object because I want to store it in a variable, but I also want to output it to the screen for your viewing pleasure. So the first one was the Go bubble sort with 100 numbers. It took about a little over 3 milliseconds to run. PowerShell ran the same bubble sort and finished in a little over 1 millisecond. And That is interesting. So that's why I say generally PowerShell won't win. This was only 100 numbers. We're going to really amp it up here. And then we have my little function. We can see PowerShell was, about 1.8 times better. So let's really amp it up now. Let's do 1,000. And now we can see Go finished in about a little over 22 milliseconds. PowerShell, it took 124. And Go was about 5.5 times faster. So PowerShell's now losing. And that's to be expected. Again, like I said at the very beginning, if you really need raw performance, especially for something like a sorting algorithm like this, PowerShell can do it, but it's probably not going to be the fastest option. And just to really drive this home, if we do 10,000, like nervous about the screen going out now. So it's still running. It's going to get there. Go finished in a little over 117 milliseconds. Took PowerShell a whole little over 7 seconds to finish, 7.7 seconds. So that's really what I wanted to address just with this. We're going to talk now more about how you can make PowerShell more performant against itself. We'll talk a little bit about C#. We'll revisit that later. But just raw PowerShell versus Go, PowerShell didn't win. So to be expected, though. And I did learn, I was going to make that function sort bubble or something like that. Apparently, sort is not an approved verb, despite sort object being there. So I learned that. So let's start with for each. This is one that back in the day, all right, there we go. Back in the day, I used to get confused. I'm like, why is there so many for eaches? There's for each the keyword, for each dash object. There's the magic method, dot for each. And then, not I say new contender, but like I said, 5 years ago, they added for each parallel. So for each the keyword, there's some differences. Basically, front loads the whole collection into memory before processing. It uses more memory, but it tends to be faster. For each object processes serially. It's using the pipeline. But you still have the benefit of having the pipeline. So you have things like you can still do begin, process, and end. And for each the magic method, I feel like it's more similar to for each the keyword. I think it was added about PowerShell 4. It seems to front load the whole collection into memory. I didn't get a lot more detail on it. Sure, I actually did start to dive into the PowerShell source code. It wasn't fruitful, so maybe one of the people on the PowerShell team can provide a little bit more context in how it's actually working, but you have those three options, and then later, for each object parallel allows you to run things in parallel. You can also run things as jobs, so we'll talk a little bit about that later on, but if you do parallel, it's going to open a bunch of PowerShell run spaces, and we're going to talk about jobs and threads a little bit later. And you can use throttle limit, just depending on how many, how you want to throttle it, usually based on, I think it's based on CPU. So let's start to compare them, though. So I've had to tweak these numbers on my desktop. I was able to do like 10 million, but this old laptop just can't cut it. And all I'm going to do here, I'm going to take this, I think it's 1 million, and I'm going to run each for each object, for each keyword, dot for each the magic method, and I'm just going to do hello number, and then I'm going to output the current number. So that's all this is doing. And let's take a look at it. So I'll just hit them all, and then we'll go back and review. So we're not going to use the time span diff here, but for each dash object took to go through those million numbers, and I'm not going to output it because it just totally crushed the terminal. We'd have to wait for all those numbers to go by. But just through the measure command, we can see it took about 2.5 seconds. That's for each dash object. For each the keyword, again, that front loads everything into memory and then processes it, took about 440 milliseconds. And for each the magic method took 1.9 seconds. And this is interesting. Actually, this lines up from what I'm usually seeing when I've been testing all this. So for each object tends to be the slower option. If I go back to, well, we'll cover that at the end. So for each object tends to be the slower option, but again, like if you need the benefit of using the PowerShell pipeline, there's a lot of things. Or if you're going to use parallel, and we'll look at that in just a second, there's a lot of benefits you might have there. I like for each the keyword. I don't know, it's just how old habits die hard. But you don't really have the pipeline capability. You're just iterating through that collection. And I don't use a lot of the magic methods. We're going to look at another magic method later. It's a nice tool to have. It seems to always fall right in the middle between for each the keyword and for each object, but know that it exists. And for each the magic method is an automatic method that ends up, it should be on all collections. I've never seen it not be on a collection, so I don't know if there's a certain collection type where you won't have that magic method, but if you just make a list in PowerShell, it should have a for each method on it. So again, considerations: does memory matter? Do you care if you're front loading everything into memory? Does the actual processing time matter more? Do you need the PowerShell pipeline? I'm not saying one of these is right, wrong, or there's a way to go. I'm not saying always use for each the keyword, because it's faster in this case. A lot of this session is going to be just know there's differences and pick the right tool. And I didn't want to stop without or move on before calling out for each with parallel. So I'm just going to do 1 through 100 here and do the same thing. We're just going to measure it, but we're going to do parallel, and we're going to do a regular for each object. And what I wanted to show here is, because parallel has the overhead of opening those run spaces, it's not always, just don't automatically like, oh, parallel is going to be faster, because it's not. It really depends on what you're doing. So in this case, like if I had long-running jobs, parallel would probably be a lot better. But where we're just iterating through 10 numbers and doing some output, parallel is actually quite slow in comparison to just using for each object. So keep that in mind when you're, I have it down below. Just don't think you can use parallel and say, oh, it's going to scream. No, it could be slower depending on what you do. So yeah, I kind of talked about the do's, the don'ts, and the considerations. So let's take a look at something else now. And there's no exact order to this. So I have these sections. It's just kind of things as I saw fit. And time dependent, a couple of them I'd say are maybe a little less applicable, but we'll take a look at that. So let's go to where object now. Oh yeah, any Magic card players in here? I don't play. I used to. For where object, we're going to be using the entire collection of every Magic card that ever was. It's just the name also, and if you can see that JSON file, it's 111 meg. So there's a lot of Magic cards, a lot. So even the zip is 33. All right, so like for each, there's where object. Where object has a couple different ways you can use it. There's the older filter script parameter, and then there's a newer style syntax. I say newer, it came out in I think PowerShell 3. And similar to for each, there's a where magic method. And one thing I actually learned putting this together, I don't use the magic methods a lot, but you can actually do some select object type functionality in the where. So I'm not going to expand the archive. That's boring. We've already done it. So let me just get all the Magic cards loaded up into a cards variable so we can start doing our filtering. Oh, and I just wanted to get 10 random cards to show you that they're actual Magic cards. I don't know. Like I said, it's been years since I played. I don't know if there's any cards with lewd names, so every time I've run this, I hope there isn't. It doesn't look like we have anything bad in there, so we maybe just got lucky. I hear laughing, so I feel like there is Magic cards with questionable names for a recorded session. But so I'm going to do 3 different wheres. I'm going to use the script block. I'm going to use the comparison statement. That's the newer style usage of where the like is a parameter. There actually are Magic cards that have cheese in the name. So these are, I could show you after. I think there's 2 in the whole set. And yeah, we're going to do the magic method. And I'm just going to copy all these because I want to keep this moving. I don't like typing in demos. That's why I do a lot of copy paste. But so let's just take a look at the first one. So my preference, this is very subjective. I like where object with the filter script. I know there's the newer syntax. I still always use the filter script. I don't know, again, old habits. We could see here with the filter script going through the whole list of magic cards to find the ones that have cheese in the name took 227 milliseconds. The comparison statement actually is faster. In all my testing, I didn't think that'd be the case, but it is. For me, I'm still, I don't know, old habits. I like the other one, but if you use the newer syntax with that comparison statement, it actually tends to be a little bit faster. We see that one finished in 150 milliseconds. And then, oh, but if you read the comment, and this is all on GitHub if you want to go peruse it, it's actually public right now. With the filter script, you can do multiple comparisons. I can say like where the card name is cheese and the card matches something else. The comparison statement only seems to let you use one single condition, so that might matter. And then the magic method was the fastest, took 107 milliseconds. And again, even though that's the fastest, I haven't used it a lot. I've seen it used. I've done it on occasion, but these are things to consider. And actually, if you're curious, because I actually was, and I did test this first. There was 2 cards that have cheese in the name for the whole set. So the cheese stands alone and the zombie cheese magician, I guess. So with that, I guess on the topic of zombie, and that's how I got here, I just wanted to show you that where has that additional functionality. So if we wanted to get where with all the zombie cards, but we also said, hey, other than all the zombie cards, give me the first 10 and the last 10 and those other 2 lines, you can do that with the magic method, which is nice if you want to not have to, if you don't want to have to deal with piping it to select object, you can do that with where. I learned that, I didn't know it. But yeah, we can get the first 10, first, last there. So again, as far as where goes, if you need the performance of .where, the magic method, use it. That might be something you need to do. Maybe you just can get by with where-object. Or if you don't want to do the pipeline at all, you can do where and then do some selection criteria within that. So just don't pick one. And like I said, there's only been a few times in my PowerShelling where I've used the magic methods, but they exist. And Kirk Monroe, I didn't say this before, but for each in the where magic methods, Kirk has an excellent write-up in PowerShell magazine about that. So go check it out. I read it quite a bit while I was putting this all together. Let's see where we're at. Let me go back. What's next? Oh yeah, this is one of my favorite ones. Lists and arrays, collections. There's some people in the audience here. They knew who they are. I'm just kidding. So I'm just throwing some guff to the front row. What do we got? Yeah, we only have the one in here, so we'll do lists, arrays. All right, this is probably one of the biggest things I see in the wild to this day that's going to impact your performance. And it's a thing that's taught when everyone's learning PowerShell. And I have this hot take. This is subjective. But if you use the open close paren to build a PowerShell array and you add to it with plus equals, that is probably one of the slowest things you can do. It's in a small scale, it's probably fine. But we're going to see that as soon as you start to try to scale that up, it's not going to work. And I have a good analogy. It's like you have a house and you buy a new couch. And you want to put the new couch in your house. Imagine if you just demolished the whole house, rebuilt it with all of your existing furniture, and then with that new couch. That's the equivalent of what that open close paren is doing with the plus equal, because every time it's just destroying the old collection, the old array, rebuilding it with the new item. So don't rebuild your whole house every time you buy a piece of furniture effectively. And let's take a look at it. So, and we're going to look at array list and generic lists in .NET. Those are my preference. I'm a stickler for strongly typed things. I usually like a generic list, but we'll take a look at that. So So I made my new PowerShell array with that plus equals. There's an add method, but you can't use it because it is truly an array. An array, by strict terms, is a fixed size collection. You can't add to it. Now we can, if we do the plus equals 1, now I've added 1, now I've added Summit, and I can see those there. But every time I'm doing that, again, it's destroying the old one and recreating it with the new thing that I'm adding, which is why the performance scales very poorly. So let's take a huge list. So we're going to do 1 through 20,000, and we're going to add each one of those in. And why is this? Oh, this is going to bother me. Let me reopen this. I was wondering why the markdown looked a little grumbly. There we go. Much better. All right. So now we're going to add 20,000 numbers to that PowerShell array. And we're going to wait. Because every one, 20,000 times, it's destroying that original collection behind the scenes and rebuilding it with the new number. And this should finish in a reasonable amount of time. If it doesn't, I can always kill this session and start it over. Environmental variables, when I've done this before, it didn't take this long, so maybe it's a little warmer in here. Maybe there's solar flares, I don't know. Eclipse, remnants of the eclipse from Monday. Now for the recording, everyone's going to know when this occurred. Wow, this is actually taking a lot longer than it should. Well, let's go back for now. Oh, actually, my whole machine may have locked up. And if it actually, this has not happened in any of my testing, but I'm going to say it was because we used the bad array in PowerShell, if that's the case. So I don't think that's the case, though. My goodness. Yeah, I'm totally dead in the water. All right, bear with me. All right, we're good. Let's go to that, because we're going to need the Wi-Fi to pull the slides back up at the end. Hey, look at that. Thanks, Chrome. All right, starting over. Well, starting from arrays. Go to my Git. And let's make it bigger so people can see. And I want to have 2 tabs. So I usually do tabs in my Kitty terminal. You're just getting a whole crash course on my whole Linux environment here. So we'll have this one called Notes, and we're going to do, a new tab. The conference Wi-Fi is slow, my goodness. And we're going to call this one Terminal. Cool. And we're going to go to Git, and we're going to go to, and where were we? We were in lists and arrays. Okay. And we're back. Yes, look at that. See? Live on the fly. And let's glow our lists and arrays so we can see where we're at. Because I'm probably going to have to put some things. I'm actually going to have to put my functions back in memory, so if that bites us in a little bit, we'll know. And my timer got squashed, so I just have to keep in mind that we have about 10 minutes left. All right, so don't use the PowerShell array. It'll crash your laptop in a live demo. It's that bad. Okay, we're back up here too, good. So I'm actually going to skip that. I don't want to tempt fate. I don't want to do the same thing twice. We're going to do an array list now, which is much more performant. Much better, good stuff. So before I do this, let me just put my function back in memory because I know I'm going to forget, I'm going to need it. So we'll go to 0, groundwork, and we're going to dot source. Oh, not our bubble sort. It's in here, right? Oh yeah, get time span. Get time span diff %, neat. Okay. So an array list is a .NET collection type. It allows you to put any, it's not strongly typed. You can put strings in it, you can put PS custom objects, you can put other array lists, you can put whatever you want in it. So I'm going to create one. I'm just going to add some stuff, and then we're going to do the big addition. We're going to add 20,000 items again. Cool, so we have it. There it is. You can see I have number 1. I have a string called Bobby Codes. And now we're going to add 20,000 items to that, and hope this doesn't crash the machine again. But this is a nice, and see, look at that. An array list doesn't crash your laptop in a demo, and it added those 20,000 in 30 seconds. Again, had the other one not crashed, it would have taken about 5 to 7 seconds. So I don't think I'm going to attempt it again, but we have about 5 to 7 seconds versus 30 milliseconds. And then my preference, again, I'm a stickler for certain things. I love when things are typed, so we're going to make a collection, system collections generic list that contains ints. And you'll see here, I'm going to try to add a string. It's going to get very crabby with me. It's going to say, oh, you can't add a string. It's not a system.int32. And then if we want to do our big addition, add 20,000 to that. We'll go ahead and do that. And we're going to modify that bottom one because we don't have the original run because of the crash. But it took about 58 milliseconds, so it's a little slower, and that's usually what I've seen in testing. And then, you know, I'm not going to do the comparison actually because we saw 30 milliseconds versus about 58. So again, I would say I do this even for small collections. I use an array list or a generic list of a type. I very seldom, if ever, use PowerShells at open close parentheses. Jokes aside, just for the recording, it should not crash your computer, but that was just very convenient timing, very comedic timing. It is much slower. It's like in the span of seconds versus milliseconds, so quite a big difference. And this is, you know, very subjective, my hot take. Just don't use it. It's not that hard to make a different type of list that's a little bit more friendly. So let's talk about the time we have. There's 2 things. We might skip custom objects versus hash tables and the filtering. Those are like 2 sentences I can give you at the end if we run out of time. So let's go to functions versus commandlets, because this was a fun one. What's faster, functions or commandlets? What do you guys think will be faster? That's a good guess. So we'll see that. We'll see that live. So a function is written in PowerShell and then parsed by PowerShell's interpreter, and then it executes what it must. A commandlet is written in C#. It's still run through the PowerShell interpreter, but you're calling a compiled DLL at the end of the day, which tends to be a lot faster than raw PowerShell code. So in that way, I have bubble sort. Bubble sort's back, and I knew that's why I didn't .source it, because I can do it here. So we're going to do the same bubble sort. I'm not going to pull it up again. It's the exact same file as before. Kudos to me for putting it in here. It's almost like I knew my laptop was going to crash mid-demo. And we also have a bubble sort implemented in C#. And I just wanted to show you what that looks like. I'm not a C# guy. There's a lot of blood, sweat, and tears to bring you this. I've done enough C# to get by over the years, but much like Go and PowerShell, it's going to parse the file. It's going to take a file in, parse it, do the bubble sort, output the numbers. And like Go, the bubble sort is its own method within the commandlet there. So with that, let's run it. So we already have, we've done that. So I'm going to run them first. The C# one is called invoke bubble sort CS. Actually, I have to import it first because I don't have that one in memory. So let me just import that. I didn't make like a full proper module, but just so you know, we see it here, command type of commandlet. It just gives it that version. So we have it. So it's invoke bubble sort CS. The PowerShell one just doesn't have the CS. So let's just compare them. And as the audience alluded to, as you guys said, the commandlet should be faster, and we should expect to see that. We'll see how much faster it is, but why didn't it like that? Let me just go back. I might have .sourced it into the wrong session. There we go. Now this should work. Cool. So the PowerShell run at the top here, 116 milliseconds, and then the C#, 11 milliseconds. And I think, yeah, we'll do this. I'll just show you the diff between the two. It's about 10 times faster, so the commandlet is faster. So this might be a good case where if you have something and you want to stay in the .NET ecosystem and you don't mind doing C# or having a compiled DLL that either has commandlets or has some functionality that ships alongside the rest of your PowerShell code, you could do it in C# and ship it, and it dovetails real nicely into PowerShell. You don't have to write Go and then have like a totally separate executable. You can still keep it all in the .NET world, which is nice. But commandlets are faster. And then this was interesting too. So there's, we have PowerShell. We have PowerShell syntax. And this one had a few different things. This one got real interesting. So yeah, so we're going to be using Moby Dick here. So that text file is the entire book of Moby Dick. So we'll start with a GUID. I'm going to measure doing new dash GUID versus using the square bracket like type accelerator syntax system.GUID with the static method of new GUID, just to show you the difference between those two. So this is something as simple as instantiating a GUID. And the difference was using PowerShell was under a millisecond, and using the system.GUID new GUID, that method, actually took 2 milliseconds. So this is one case where PowerShell was faster. And this whole section 7, native PowerShell versus .NET objects, it really depends. This section has a huge caveat. It really depends on what you're doing. So in this case, something as simple as making a GUID, new dash GUID was faster. And if you're curious, that's not a function, that's a compiled commandlet that ships with PowerShell. So that was a commandlet. But we're doing that commandlet versus just using the raw.NET within PowerShell. So parsing a file, here's where it gets a little different. So I'm going to do get content. I'm going to pass the path. We're going to parse the entirety of Moby Dick. And I'm going to use .NET. I'm going to do a system.io.file. We're going to use read all text. And I'm going to pass it Moby Dick. We'll see what's faster. And we can see here that get content took 91 milliseconds, but the system.io.file took 3 milliseconds. And it was a difference of, the system.io.file is about 24 times faster. So just because the new GUID was faster, in this case we can see something like parsing a whole file actually takes a little bit longer with using PowerShell's get content. So again, that's why it's a big it depends. And similarly, this one, we're just instantiating an array list. I wanted to measure the difference between using new object with type name and then the type name versus just using the square bracket syntax with the new constructor. And let's take a look at that. This is the one I always forget what's faster. So let's find out together. So it took PowerShell's new object under a millisecond, just 6,974 ticks. And it took the square bracket syntax a lot less time. It only took 1,076 ticks. So in this case, new object's slower, which I kind of expected. So keep that in mind. But the difference is pretty negligible. And in our remaining time, there's one more thing. So, let's look at jobs. Let's look at jobs real quick. And then I'll just tell you about the other two. One is somewhat related. One is kind of apples to oranges, but we'll just address that at the end. So talking about jobs. There's different kinds of jobs. Jobs were introduced, I think, in PowerShell 2. That's what I wrote back when I did this research. And thread jobs were introduced in PowerShell 6.1. And the difference is jobs are going to spin up a separate PowerShell process. So I'm on Linux here. If I use top, I can actually see all those PWSH processes spin up. You can open Task Manager on Windows to see it. If you're on Mac, I have no idea. I don't use Mac. The difference is thread jobs, it will run different threads within the same PowerShell job or the same PowerShell instance or process. That's the word I'm looking for. So there's difference. We're going to see the difference in performance. However, there's a lot of considerations here when you're planning on what you want to run, because you might think, oh, well, maybe thread jobs is newer. That's better. Not necessarily. It really depends on the context. So I have a file where we're going to basically, well, let's just do this first before we get to the Fibonacci sequence. So I'm just going 1 through 20, and I'm waiting 1 second, or I'm running the job for 1 second, and then releasing it. And I'm going to do that with start job, and I'm going to do that with start thread job. And it takes a minute for it to go, but in this case, jobs is faster, as we can see. Took 2 seconds, a little over 2 seconds. Took thread job, a little over 4 seconds. So again, difference. Thread jobs running that all-in-one PowerShell process, where jobs are spinning up temporarily multiple different PowerShell processes to run it, and then you get your terminal back. Or you could do like wait job and then receive job, but we didn't do that. We weren't being fancy for the sake of this. So I have this get Fibonacci. It just does the Fibonacci sequence calculation. You can Wikipedia that if you want. And it's just going to output. I'm going to say, get me the 19th number in the Fibonacci sequence, which I think is 4,000 something. Oop. All right. So if I just run this as is, it's going to output the 19th number 10 times. Which, yeah, 4181. So that's the 19th number in the Fibonacci sequence. Now let's take a look at start job and thread job again with the measure command. We'll clean up our terminal. And in this case, that took the job 58 milliseconds. It took thread job 18 milliseconds. So again, this is something that didn't take time to process, like when we were just waiting 1 second. And there may be a case where you want to do thread job because what you're running, you're going to get more performance out of thread job than you will with start job. The issue being were all these considerations. So maybe with start job, maybe what you're running, you don't want to open a bunch of different PowerShell processes. That matters. Where thread job's just going to run use multiple threads within the same PowerShell process. Start thread job's great, but if your PowerShell process dies, if you try to do like a PowerShell array and it crashes the whole process, I'm joking. But if your process dies, it's gone. So you're going to lose all the jobs that we're running. Where at least with start job, if one process dies, that process was its own instance of PowerShell. So that might matter. Again, use the right tool for the job here. It really just depends on what you're processing and what you're trying to do. So the last thing, we'll just go back to the slides real quick and wrap it up because we're basically at time. But the two sections we did not cover was hash tables versus PS custom objects. Long story short, they're both data structures in PowerShell. I'd say it's kind of an apples to oranges comparison. Hash tables are definitely a little bit more performant, but there's some things with PS custom objects that you might want. So it really just depends on what you're doing. And then the last thing was filter left, format right. But long story short, the only example there is if you get process on your machine, you can filter by using the name. So you can filter for process in the get process command letter function, which is going to be faster than if you pipe that whole list of processes over to where object, because now you have to pass everything along the pipeline and filter in a totally different command. So when it comes to filtering, just if you can filter up front or with the command you're running, do it. AD is probably another good example. I know AD has a filter. A lot of the AD commandlets have a filter built into them. That's going to be a lot faster than trying to pipe it to a filter. So Use the right tool for the job. Maybe your PowerShell just needs some optimization. You can make it blazingly fast. You just might need to tweak it a little bit. You might just have some code that's non-performant. And if you've hit the limits, maybe you need to explore C# if you want to stay within .NET. Otherwise, look at C or Go or Rust or any language that's probably going to be more performant. And that's it. That's all I got.